Hello people, good morning. So this is going to be a super quick video on the redshift and why it seems to me like it should be a geometric thing that was totally expected if the universe was infinite. Once you start to say the Big Bang closed off the universe is limited physically, dimensionally, like physically in size. It's only 13.8 billion light years, and if you say that's an absolute rather than a locally observed condition, then well, then you have to figure other things out. But if the universe is actually truly infinite, then this seems expected. Okay, because let's look at the universe. We're looking for an infinite surface, right? An infinite surface. But it's not completely flat. It's very, very flat and appears very flat just because distribution is flat because we're not in a closed thing. But there's still gravity and mass curves space, and space has an innate energy density, and therefore there should be, in fact, an innate curvature to space. Now, whether we can measure it or not, or because we're part of it, that becomes problematic is another thing. And let's look at the top of my diagram up here. Here is you. We are the center of the universe because we're where we're observing from. Okay, here's you. Now, we're looking for a surface for space that is infinite. Okay, so there's no closure to this space. We're looking for a simple geometric form because the universe likes to be path of least action. So let's find the simple geometric form that will solve this. Oh, how about a parabola, right? A parabola keeps on going forever. The volume underneath the parabola is infinite. The angle of deflection along the parabola has a very consistent curve to it. Let's say we're at the bottom. This is you. We're at the bottom, the top, however you want to see it, okay? So you look a little far away, and because of the curvature of space, you get a little bit of a deflection, a little bit of redshift, because space is now, right? Instead of being this long, the line is this long. It got stretched, and now it's at this angle, and now it's at this angle. And the angle represents the amount of curvature or stretch needed once you impose a simple graph, Euclidean type or Cartesian type graph, on top of a curved space-time. What happens is as you go further and further away, the deflection becomes greater and greater of an angle, which means that the light is stretched more, space is stretched more. This is a lower frequency now because now it's this long instead of just being this long. And eventually that happens to the point where we can't see it anymore because essentially it's a DC signal. It's so low a signal, so low frequency a signal, that we have trouble detecting it. You know, how do we know that that's actually a signal and not just random fluctuations of background, right? This is the shape that contains infinity. If it was a closed shape, if it was a sphere, that would be a limited universe. Infinite universe, but here is the limit of the observable universe because at some point the curvature becomes so great that we have problems seeing it. To me, this is the most simple and logical explanation for the redshift, is that it's just a geometric aspect of the universe. The further away you go, the more the curvature of space increases, the more light is pulled out until, you know, we just can't see forever. When you're standing on a sphere, here we are on Earth. Okay, you're standing on Earth, and you're, what, 5-6 feet above the surface of the Earth? When you look around, there is a limit, your horizon limit, and it doesn't matter how far you go out, you will never be able to see more than half, not even half, of a sphere. You will never see even half of the sphere. You will always be shy. thanks to gravitational effects, if this was a monstrous sphere and this would be curved around, then I guess you could see behind, like with black holes, because they don't exist, because you can't see them, because light is curved around them so badly. But I didn't want this video to get this long. Boom, there's the core. I don't know, it just seems to me like, there, that explains it. What do we need a Big Bang for?